Assalamu alaikum students. You're watching our channel Mathematics with Abdul. Previously we have done the upper bound. We have found the upper bound of a rectangle. So upper bound of a floor area of a rectangle room with these measurements. No? So now we will find the lower bounds of the floor area. No? So first you should note. Let's write the rectangle first. Okay, how it will look like now. So this is our length, 5.26 meter, but we have to convert this length into a meters, because here nearest centimeter, which is our accuracy, given in a centimeter. So this is 1 centimeter. So while finding the error, you have to just accuracy divided by 1 divided by 2, you will get 0.5 centimeter. So this will become our error. So this was just an information for that, no? Because this was in a centimeters, accuracy was in a centimeter, error is in a centimeter. We should have to convert 5.26 into a centimeters. So while converting 5.26 into a centimeter, the length we will get 526 centimeter. As you should know, 1 meter is equal to 100 centimeter. So 3.89 meter will be converted into a centimeter. It becomes 389 centimeter. So now we have to, what we have to find is the area, upper bound and lower bound. Previously we have found the upper bound, now we'll find the lower bound. So the lower bound of area is lower bound of length and length into a lower bound of a width. So the lower bound of a length, while finding this, this is simple, like 526 minus 0.5 into 389 minus 0.5. So in the last we will get 525.5 into 388.5. So in the last we will get, let's see how much. Let's use the calculator. So by using the calculator, we will get 525.5 into 388.5. So now we got 2.04156. So 2.0415675 into 10 raised to 5. So now this is into a centimeter square. So so if you want to convert this into a meter square, you have to do is 0.515675 into 10 raised to power 5 divided by 100 into 100. So basically this will become a 10 raised to power 4. So let's write 10 raised to power 4. So while subtracting this and this, we will get just a 10 raised to power 1. So in above, it will become a 2.04156 5675 into 10 raised to power 1. So we will get 20.415675. This is in a meter square because we are dividing this now. This, but we want that the answer should be in a three significant figure. So we will get 20.5 meters square. So yeah, previously it was you can check from the previous notes. So now we will do the question number 3 for more concept. No? So this is question number 3. Calculate the upper and lower bounds of the distance traveled for each of these pairs of speed and time. So, and given is give your answer to three significant figure. So now the part A is 92.4 centimeter per second for 12.3 seconds. So so we have given the speed and the time. So now we have to find the upper and lower bound distance traveled. So both values of three significant figure. So now the solution for this is the first of all you have to find the accuracy. So now it says both values of three significant figure. So now 4 is on the third significant figure and the 3 is on third significant figure. So now the accuracy for this will become 0.01. So oh sorry, let me 0.10. Yeah, 10th place of a number. So the accuracy will become 0.10 and the error will become 0.10 divided by 2. So this is 0.05. So this is error term. Now the question says we have to find the upper and lower bound. No? So first let's find the upper bound first. Upper bound of the distance. So upper bound of a distance will become upper bound of distance is upper bound of average speed into upper bound of time. So upper bound of a speed, now it will become 92.4 plus 0.05, because in upper bound finding we will add this term, added term. So we will multiply with now upper bound of a time, 12.3 plus 0.05. So now we will add these terms, 92.45 into 12.35. So now when we multiply these terms, the answer we will get is, let's use the calculator. Now we'll multiply 92.45 into 12.35. So now our answer is let me write 1141 point decimal 75. So it says give your answer to three significant figures. So this is our first significant figure, this is second, this is third. So the answer will become 140, because here is just a 1, so which is less than 5, so it will become 0. So now the distance is in 1140 centimeter. So now we have to find the lower bound. Same question. We have to find the lower bound of distance. So for finding the lower bound of a distance, you have to find the lower bound of speed into lower bound of time. So lower bound of a speed will become, we have to minus 92.40. This is given the speed, so we will minus the term 0.05 and multiply with 12.30 minus 0.05. So this is our lower bound of a speed, and this is our lower bound of a time. So the unit for this is meter per second, and the unit for this is second. So sorry. Now here is given centimeter per second. So here is given the seconds. So the lower bound for this speed will become 92.35 into 12.25. So when you will multiply these terms, you will get 131.2875, and while rounding this to three significant figure, you will get 1130, and this is in centimeters. So this is our final answer. This is the lower bound of distance. So Now we have a part D for this. Is let's do the part D for this. Here the part D says 4.61 meter per second, the speed for 2.08 seconds. So some car or some person or some bike has run 5.61 meter per second to 2.8 seconds. So now the value, both values to, so it says both values to three significant figure. So the third significant figure is this one, and here is 8, 1 and 8. So now our accuracy term will become, first we find the accuracy. So the accuracy will become 0.01. So because the accuracy we are writing is this 8 is on the 100th place. So the one will come on the 100th place. So now finding the error, you will get 0.0100 divided by 2, you will get 0.005. Or you will write just 0.005. So this is our error term. Now for the finding of upper bound of distance. Upper bound of a distance is upper bound of average speed into upper bound of time. So now here the average speed is the 5.61. So upper bound will become 0.005 into 2.08, add plus 0.005. So this will become this. So while adding, you will get 5.615 into 2.085. So now the answer will become, let's find the answer for this. So 5.615 into 2.085. So the answer is 11.70. 11.70 meter. So this is in the upper bound of a distance. So this should be on in a this should be in a three significant figures. So the answer is in the three significant figures. So this is three significant figure. So this is rounded basically, I'm saying. So now the lower bound of distance. So the lower bound of average speed first into lower bound of time. So for finding the lower bound of a speed here, you will just subtract 5.61 minus 0.05 into it's 2.08 subtract 0.05. So now we get the answer for this is 5.56, and into you will get 2.03. So when we multiply these both quantities, this is 5.56 into 2.03. So we get answer is 11.28. 11.28. So the number 2 is on third significant figure. While rounding, we will get 11.30. So because 8 is greater than 5, so we will get this. So now the answer we got is 11.30 meter. So this is it. So this is for it. Next we will do the question number 4. Now you can compare also. This is the upper bound and this is the lower bound. So this quite is a clear, the number is increasing, not decreasing type.